Start recording. Okay, now we are recording. All right, so your instructions will be very close to this, which means your exam is also individual. Do not you know collaborate during the exam. But when you're studying, your collaboration is fine. Okay, in fact, you can even collaborate with people who have taken this class before. Okay, some of the tutors downstairs in Mesa are they have taken this class before. Paper-based content that was prepared prior to the exam can be used as long as there's no interaction or collaboration in the class. So that means, yes, I have this piece of paper that I brought along with me, but do not exchange that piece of paper with people in the class during the exam. So that's what that is referring to. Now, can you guys work together, collaborate, and bring the same pieces of paper with you to the exam? Yes. Okay, so you can study together, come up with exactly the same material to bring with you to the exam. That is not a problem. The problem is when people, exchange paper or content during the exam. That would be a problem. Is that okay? All right. There's no limitation as to how much stuff you can bring with you. So if you want to bring books with you, that's fine. If you can find people who have taken this class for the past 15 years and make a compilation of all that material, you can bring that with you too. Not sure whether that's going to be helpful, but you can. All right. If you have a list of every single way to create functions, given three elements in the domain and four elements in the codomain, and you bring a table of which ones are injective, which ones are surjective, and so on, and so you can just do a table lookup, you know, that's fine with me too. But generating that table itself, can be a little bit of a chore. You can probably ask AI to do it. The question is, do you think AI is going to do the job correctly or not? Can you tell whether it's actually giving you the correct answers or not? So, anyway, as long as it's on paper, like physical paper made out of dead trees, it's okay. E-paper does not count as actual paper for this purpose. Are we good so far? All right. Grading is based on explanations and steps, demonstration of understanding of knowledge and problem solving skills, and not necessarily the final answer. So, if the question asks you for explanation and steps of derivation, then you have to give me those steps in order to get the points. On the other hand, if the question is simply asking what is blah blah blah, then you do not have to give me an explanation because the question does not ask for the explanation. Sufficient explanation means that your answer connects the definitions and concepts that we talk about in the class, and using logical steps and mathematical steps, you connect it to the answer. Okay, so that's what I mean by derivation or a sufficient explanation. In a multi-part question, an incorrect answer to an earlier part may or may not lead to partial credit for a later part. Okay, so that means if there are like three parts to a question, A, B, and C, you get part one wrong, but part C and part B are consistent with part A. I might give you partial credit for that. Okay, but it's not guaranteed. It is all depending on the scenario. All questions carry equal weight, which is pretty useful. Okay, because this can help you potentially to plan for the exam. the Basically how much time to spend on each question, okay, so that you can all okay, what is the general strategy when you take a test when you already know all the questions carry the same number of points? What is the next thing you're going to do? Hmm? So, say again? The easiest to the hardest. Okay, so the first thing I would do is to just count the number of questions so that I can come up with, okay, I probably want to spend this much time per question. So I come up with that idea first, and then I usually leave a little bit of time at the end so I can have some time to go back to the hardest question or the one that I could not finish. Then, yes, then I will go for the easiest one first, and then go to the hardest one last. Okay, very good. Um, let's see. In the notations, for all st in F, blah blah blah, st is considered a single element of the set F. Okay, so this is a way for me to specify for every two tuple in F, and then in that two tuple, s and t are the items in the two tuple. So this is just a notation thing. I want to make it clear to people in the class. And in the previous semester, I have decided to only answer the first five of the first seven questions because there are too many. I kind of go like, seven questions is a lot. Maybe I'll just have people answer five of the seven. So that means if people answer all five out of seven correctly out of the first seven, then they have gotten all the points available for the first five questions. And then there's one that is not a part of the first seven, and that one is mandatory. So there are six questions that people need to answer in this case. Okay. Now, whether your test is going to have the same setup or the same structure, I haven't decided yet. Okay, so you have to read the instructions that is specific to your exam and do not make assumptions about your exam being the same as this particular exam. Are we good so far? All right. So we are now moving on to question number one. Okay, so we'll work on it. You are given the following: X is a set with C, K, and G in it. Y is a set with A, K, and H in it. F is a set with K, K, G, A, C, A, and C, H in it. So there are two tuples in it. Part one is asking for 16 points. It is asking you what is the value of blah 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 blah. Okay, this is the entire thing. Okay, it is a quantified expression. I'm asking you what is the value of for all u in y. There exists xy in f such that y and u are the same. If the answer is false, show one element that makes the underlined expression false. So that's what you're asked. So now the question is, okay, how do we evaluate this, and what is the answer? All right. What do you think? What is the answer? How do you approach this particular question? Yes, go ahead. Mm, it won't be that easy because if I say if the answer is false, show me one element u. So you're saying that when u equals to a, the underlined portion is false. hmm All right. So let's go ahead and take a look at the statement. So you're probably right, but we'll take a look at the statement and find out exactly what it is saying. Y is this particular set here. So we have to say, okay, what if u equals to a? What if u equals to k? And what if u equals to h? Okay, so we'll pick one and say, okay, what if u equals to lowercase a? Then we already know what is u. U is just lowercase a. So now the question is there a two tuple xy in F, okay, such that y, which is from here, equals to a. So y is the second item of the two tuple, and we already said that u equals to a, right? So that means, yeah, that we can find it, CA, okay? So that means, the underlined portion is not false when lowercase u equals to lowercase a. So that doesn't work out. Okay, so we're going to plug in the other two possible values, right? So we're going to plug in, what about lowercase k? So now we say, okay, we are looking for something that is blah blah k in f. Yeah, we find it, kk. That works. So your last hope of making this entire expression false is lowercase h. So you substitute h into the U. So now you're saying, okay, does something end with H in a two tuple in F? The answer is yes. CH ends with H, or the second item of CH is H. So now we have already tried out A, K, and H. For every single one of those, the underlined statement is true. So that means the value of this quantified expression is true. Exactly. So if it is true, there's nothing else you need to do other than answering, just say, okay, just write down true here. All right. And then for another 16 points, it's asking you what is the value of blah, 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 blah. Okay, another quantified expression. So this time I'm asking for there exists u in x such that for every two tuple vw in f, u does not equal to v. Okay, so what is the result of that? So some of you might have noticed that, it looks like we're looking at properties of functions. And you'll be right, okay? We are actually looking at properties of functions. So if you look at it from that perspective, then you go like, which one can it be? So this one is asking, okay, can we find an element u from x? So that means c, k, or g, such that for every two tuple in f, u and v are different. We don't care about the w, okay? We are just saying, okay, we have to find something in x so that everything in f that does not start with the u that we have chosen. Okay, so that is the interpretation. So now we can take a quick look at that. So we ask, okay, what if u equals to c? Do we have something that starts with CA? Okay, so CA, so that means this expression, the underlined portion, is false when U equals to C. That doesn't work out for me. Okay, what about K? When U equals to K, we go like, let's see here. Okay, KK starts with a K. And then when we have G, then we look at this whole thing, we look at this set here, and we go, okay, we have a GA here. So that means no matter which element you choose from X, this part here is always false. So that means that the entire quantified expression is false. Are we good so far? And because the entire quantified expression is false, you don't have anything else to do because the question says if the answer is true, then you have to do something else. But if the answer is false, you just have to write down false. Are we good so far? Yes. Okay. All right. So now for another 16 points, we look at question number 3 or part 3 of the same question. So this time it is a little bit longer. Okay. It asks, Does there exists UV of f and xy also of f? So that means UV is an element of f, xy is an element of f. There's no restriction whether they can be the same or not. Okay, so right now we can go like, okay, just pick, UV, xy, both as elements from f. The actual expression I want to evaluate is v equals y. So that means the second part of the two tuple are the same, and yet the first part of the two tuples are different. So I'm asking, can we find a case like this? Okay, they end up with the same thing, but they start with different things. Okay, so you look at the set that is given to you and you go like, yeah, in this case, we do find something like that because GA and CA, they both end with A, but they do not start with the same element. One starts with G, the other one starts with an A. So in this case, since the answer is in fact true, you have to show the two tuples. And in this case, the two tuples would be GA as one two tuple, CA as the other two tuple. Yep. Hmm? And it is being recorded. Okay. Yep, it is being recorded. So unless something catastrophic happens to my computer, like the Mission Impossible thing happens to my hard drive. Okay, Do you guys understand what I'm referring to? Going up in smoke. Yep. So unless something like that happens, we're gonna have a recording of everything today. But if I were you, I would not leave anything to chance. It is called Murphy's Law. Hmm? Yep. No, Murphy's Law says, okay, that's one of Murphy's Law, right? Yeah, but Murphy's Law basically says, don't count on anything. The more you count on something to happen, the more likely it won't happen, and vice versa. All right, so we are down to number 4. What is the value of there exists UV in F such that it is not the case that U is in X or it is not the case that V is in Y? If the answer is true, show which two tuple UV in F makes satisfy this requirement. Okay, so let's go ahead and check. KK, is K found in X? Yes. Is K found in Y? Yes. Okay, well, that means this OR is going to be false. Fine, let's move on to the next one. Is G in X? Yes. Is A in Y? Yes. So that means because these are negated, so that means it once again it is false or false, which means the whole thing is false. Okay, time to move on to CA. C is in X, A is in Y. So once again, the underlined portion is false. And then lastly, we have CH. C is in X, H is in Y. So once again, the underlined portion is also false. So that since so the correct answer here is just false because the second part says if the answer is true, but since it's false, you don't have to work any further compared to this. And then we have part number 5. Okay, so part number 5 is here. What is the value of there exists UV in F, there exists XY in F such that, okay, this is a little bit different from the one before, such that U and X are the same, which means the first of the two tuples, the first of the two tuples are the same, and yet the second item of the two tuples are different. Okay, so let's go ahead and check. Okay, so I have to scroll back a little bit. So we don't have that case here. Okay, so no matter how you choose the two tuples, UV and XY, in fact, we cannot satisfy this requirement. We cannot find two tuples such that um, I mean, the only way to make the first part here happen is to choose the same two tuples for both UV and XY, but that automatically makes this condition false because they would end up with the V and the Y being the same. So that means for every way to choose XY and UV, the underlined portion is false. So once again, the answer to this question is false, which means there's no second part that you have to answer in this case. Yes. See, oh, you're right. Okay, I missed that. Thank you. Very good. Okay, so you are correct. In this case, for number 5, the answer is actually true because we have CACH. They both start with C, and yet the second item of the two tuples are different. One is A and one is H. Thank you. Very good observation. All right, so we have the 5 questions answered now, and then number 6 has its own individual parts. What is F? Um, okay, so now we ask this question. What is this asking? I'm not asking for the answer itself, but exactly what is, okay, let me highlight the portion that I'm working at this point. So what is this part asking? What is that notation? I'm asking you whether f can be considered a function mapping from the domain x to the codomain y. Okay, it is not confirming or affirming that f is indeed a function. It is asking whether it is a function or not. So points are allocated to the subparts. For each subpart, the answer should indicate which part and its value. Okay, so let's go ahead and go to 6.1, which has its own subparts. So 6.1 itself is saying, okay, if this is true, quote which previous parts and parts of answer leading to this conclusion. The answer is that is not the case. F is not a function. But since f is not a function, that means we have to get to the second part here. Okay, so out of these two, you can only answer part one or part two. So part two, for 20%, it is asking if x is not a function using excuse me, if f is not a function using x as a domain, y as a codomain, which previous parts or parts of the answer lead to this conclusion? Okay, which parts? Yes. Okay, but you're not answering the question. Okay, I understand your reasoning. So, but what is the correct way to answer this question? So, quote which previous part, okay, meaning one, two, three, four, or five, and what answer did we get that lead you to believe that f is not a function? Number five, that is correct. So, number five being true means we have we have one element from the domain X mapping to two things in the codomain. That should not happen if f is a function. So the correct way to answer the last part here, which is part two, is part five from before has an answer of true, and that is why f is not a function. Are we good so far? All right. So that sounds like a lot, when the next six questions are of the same type. Yes. You say part five is false because it says here which previous part? It is five. And oh, okay, I guess you just say part five in this case because it does not mention, um, yeah. So in this case, if you just mention part five, it'll be fine. Yep. All right. So that means the other parts probably have something to do with functions or properties of a function too, except it does, they are not really needed. You don't need to interpret those other parts like that in question number one. So now we take a look at question number two. Okay, here's question number two, and then we try to answer the same questions. Okay, so we'll start with part one. So part one is really asking, so now the format of each question is about the same. The structure is the same, but the definition of x, y, and f are different. Okay, so that means what you have already learned about parts one, two, three, four, five, you can recycle your understanding here, except you just plug in different values as x, y, and f. Yes. No, you just leave it like this. You do not answer part one at all. So this means this entire portion here, you don't want to have any answer. You just go straight to two, and then you just say, it is false because of number five. Yep. hmm All right. So moving on to question number two. All right, so now that we understand that, oh, okay, this whole thing has to do with functions and properties of a function, you might want to take a look at the actual quantified expression and say, okay, what exactly is it asking about? Okay, so in this case, because y is considered as a codomain, later on in that part, so now we're really asking for every element in the codomain, blah 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 blah. Okay, so the question now is, what is the blah 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 blah, which is underlined. The underlined portion in this case simply means, oh, there is something in F where it specifies a mapping to the element from the codomain. So what that really is asking, what part one is really asking in this case, is is every element in Y mapped to by F? That is what it's really asking. Are we good so far? Okay. So that by itself has its own answer. Okay, if f indeed is a function, what property of a function is part 1 corresponding to? That is correct. It has to do with surjectiveness because when a function is surjective, all the elements in the codomain are mapped to. So the answer to number 1 has to do with surjectiveness. Now, is it surjective when the answer is true, or is it surjective when the answer is false? Mm, that's something else, okay? But we can actually tag it as, okay, it has something to do with surjectiveness. We good? All right. So you look at this one and you ask, okay, is everything in Y mapped to by F? Now, F may be a function, may not be a function. It doesn't really matter. We're just looking at mapping in this case. So we say, okay, is D mapped to? Nope. Okay, well, if D is not mapped to, that means not everything in Y is mapped to. So that means the answer is false in this case. And then you have to show the element U from Y that is not mapped to. In this case, it's just D. So lowercase, so you have to first answer false, and then you have to say U equals to D in order to make the underlined portion false. That is correct. Yep. Is that okay? Does everybody understand the format of the answer? Yep, yep. All right. So what about part 2? Okay, so you might want to jot down a little bit of a note, when you're answering these questions, because since they all have the same format, so question number 1 has to do with surjectiveness. Okay. What about number 2? What about part 2? So part 2 is saying for every element in what we think is the domain, okay, and what is it asking about that element from quote unquote the domain? It's asking, do we have a mapping in F such, okay, for every mapping in F that U is not mapped from? That's what it's asking. Okay, let me say that one more time. Okay, you pick something from X and we think X is the domain. This is asking, is X not mapping to anything at all in F? That's what the underlined portion is asking. Okay, so this really has to do with whether F is even a function or not, just like number 5. So number 2 and number 5 are both important questions to ask to determine whether F is a function or not. Function number 5 is asking, am I mapping the same element from the domain to two different things in the codomain? That makes F a mapping, but not a function. Number 2 is asking, am I mapping each element from the domain to at least one and only one thing in the to at least one thing in the codomain? That's what it's asking. And in this case, let's check. So we have A mapping to B. Okay, good. H is mapping to H. B is also mapping to H. So that means the answer to number 2 is false. It is false because it is a negated thing. So, but because it is false, we also know that F is, at least up to this point, a function. Because if number 2 is answering true, that means we have found at least one element in the domain, okay, from X that is not mapping to anything at all in the codomain. And that cannot happen when F is a function. Is that okay? All right. So for this particular case, number 2 or part 2 is going to be false, which means you don't have to follow up with anything. So we get to 3, okay, same thing. So now we are asking the same thing. It's like, okay, what does this have anything to do with functions or properties of a function? So this one is looking at two elements, or I shouldn't say two, it's looking at UV, XY, both as elements from F. They may or may not be the same thing. And I'm asking whether the underlined portion, the conjunction, is going to be true or not. Can I find at least one case where UV as one element x, y as one element. They can be the same, they may be different, such that this conjunction is true. But what exactly is it asking? The conjunction states that v and y, they have to be the same. So those would be corresponding to what they map to. So we are asking, do we have two things mapping to the same thing? Okay. So what property does it have to do with in this case? Hmm? Injection. Yep. Injectiveness is what it's asking. So if the conjunction here is true for at least one way of choosing an element of F and another element from F, that means we are mapping two things from the domain to the same thing in the codomain, which means F is blah 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 injection. What is the blah blah blah? Is or is not? It is not. That is correct. So that means, if the answer is true, then F is not an injection. That's assuming F itself is a function to begin with. So what about in this case? I can see that H is mapped to H and B is also mapped to H. So that means the answer is actually true in this case. So now we have to specify the two tuples. One is HH, the other one is BH, and that makes the underlined portion true. Is that okay? All right. So we are moving on to the next line here. All right. So it's a little okay. Let me see if I can. Yeah, I'm maximizing the screen so we can show. Hopefully, show everything that we need to see. So we are now moving to number 4. So the first thing is, okay, what does it have to do with functions? Okay, so we are looking for one thing, one element in F in the mapping, such that okay, I shouldn't say either, U is not from X or V is not from Y. In other words, I'm looking at the mapping itself to make sure that it is a subset of the Cartesian product between X and Y. Let me say that one more time in a slightly different way. If F is not a subset or it contains elements other than the Cartesian product of X and Y, then this would have been true. Do we have any questions about that statement? Do you want me to say that again? Okay. Okay. So what number 4 is asking is really, um, is every element of F, is F a subset? Okay, that's what it's asking. Is F a subset of the Cartesian product of X and Y? But the answer is reversed. The polarity is reversed. So the more proper way to ask to kind of to phrase the question is whether or not, or is it true or is it false that F is not a subset of the Cartesian product between X and Y? Hmm? Yeah, because if if the first item of the two tuple does not come from X, or the second item of the two tuple does not come from Y, they both would disqualify the fact that F is a subset of the Cartesian product between X and Y, right? Yep. Yes. Yep. So in the class, I have compared the existential quantifier, which is the there exist, as a gigantic or statement, and then the universal quantifier is a gigantic and statement. Yep. All right. So um, so number 4 also needs to be true in order for f to be a function, because in order for f to be a function, it also has to be a subset of the Cartesian product between x and y. Is that okay? So now we have actually 2, 4, and 5 related to whether f is even a function or not. The other two, namely number 1 and number 3, would determine whether it is injective or whether it is surjective. Those two relate to injectiveness and surjectiveness. All right, so we're moving on to 5, but we just came from 5 earlier. So number 5 is really asking, okay, let me scroll to, okay, this is good. So number 5 is really asking, um, is one thing mapping to two different things in F? Because if that is the case, then F is not a function. Is that okay? So in this case, A maps to B, H maps to H, B maps to H. So that means number 5 would return an answer of false because we cannot find one thing from X that maps to two different things in Y. Now we found the other one, right? There are two things from X map to the same thing in Y, but that's not what number 5 is asking. Are we good so far? So for number 4, it is false. So number 4 is false when F is a subset of X Cartesian product with Y. Yep, it is inverting that. Correct. Yep. So you have to watch out for the inversion of what we're looking for. Yep. Well, if we don't have the negation sign, then we have a different problem. Because if you don't have the negation sign, then you're only asking for, oh, we just need the first item of the two tuple to come from X or the second item of the two tuple coming from Y, which is also not what we want. Because if you are to take out the negation sign, then you should convert the OR to an AND because we need the AND in order to make sure that both items, one come from X, the second item, and the second item comes from Y. So a regular OR is not going to work. All right, so getting to number 5, the answer is false. So that means we don't have anything else to demonstrate. So now we get to number 6. Okay, this is the first time in number 6 that number 1 is going to be true. We indeed have a function, but then you have to tell me which parts of the previous items you know tell us that f is indeed a function. So we worked that out already. That would be number 2. It would be number 4 and number 5. So 2, 4, 5 are the parts that lead to this conclusion. So for 10%, you have to show 2, 4, 5. And then for 5 more percent, we have to say whether it is injective or not, and which part tells us whether it is injective or not. So since we have 2, 4, 5 already used just to determine whether f is a function, so 1 and 3 are the only two left that has anything to do with injectiveness and surjectiveness. So when you go back to 1, so 1 has to do with, let me see. This has to do with surjectiveness. So that means 5 or 3 is the one that has to do with injectiveness. So that means for part 6.1.1, the answer is going to be 3. Okay, part 3 determines whether F is injective or not. So is F injective in this case? It is not injective. Okay, so part 3. So you have to answer the two parts. One is it is not injective. The second part is part 3 of the previous part tell us that it is not injective. Is that okay? So you have to remember two parts of the answer. So now for number 2, we have to use, I guess, part 1 because that's the only one that we have not used. So you say, okay, so first of all, is it surjective? Let's take a look. It is non-surjective because I can see that D is not used in Y. Okay, But part one is the reason why we know it is not surjective. So the proper answer of 6.1.2 is it is not surjective, and part one, answer part one, part one is what tells us that it is not surjective. Are we good so far? I can send you the mechanically generated key, so you don't have to write down the actual correct answer. Okay, but it is the reasoning that is the most important. Okay, how do we figure out the answer to each part, and how do we relate each part to the concepts of whether a mapping is a function, and if it is a function, whether it is injective or surjective. Are we good? Okay. So I'm going to say something not to scare you, but to prepare you. There's a very thin line between those two. Okay, you guys are not smiling. So that means either you're not getting the joke or you don't think it is a joke. See, I can apply logic even to interpret whether you guys are thinking it is not a joke, or I don't think or either you don't understand it is a joke to begin with, or you do not agree that it is a joke. Okay, anyway, the statement is, if you see these questions already in a previous exam, that will not be the same questions that you will be getting. You'll be, I will have different questions to see whether you understand the same concepts. So there are certain things you know for certain, okay? The scope itself only consists of the Boolean operators that we have talked about. Conjunction, disjunction, negation, implication, and equivalence. So those are the five Boolean operators that we have talked about, I believe, on day one, okay, of this entire semester. So that's part of the scope. Set operations and operators, okay? Element of, um, intersection, union, okay, the minus or the difference symbol, those things are also in the scope of the exam. Now, only element of is a part of these questions, so they are not, this is not including everything under the sun, okay? It's only including a, do I dare, subset of the things that we have talked about. Okay, what other concepts is actually, am I testing here? So the other concept has to do with functions, okay? Whether a mapping is a function or not. Oh, by the way, there's also Cartesian product, okay? So the concept of a Cartesian product is hidden somewhere, but we also have the concept of functions, whether a mapping is a function or not. Okay, so you can see how parts 2, 4, and 5 have to do with whether f is even a function or not. And then if we know it is a function, then we also need to know whether it is injective or not, and also whether it is surjective or not. So number 1 and number 3 in this particular case have to do with whether it is injective or not. So the scope of the exam is the same. How the questions are asked to see whether you understand the whole concept, all of those concepts, is guaranteed to be different compared to what you're seeing here. Are we good so far? Okay, so knowing that, how are you going to prepare for the exam? Mhm. So the first thing I would do is to make sure that I have a list of all the symbols and all the definitions. Okay, in other words, I would kind of put all the Boolean operators into one corner. Okay, we only got 5 of those. I will put all the set related operators into another section. I will put all the things that relate to functions also into another section. In other words, I will make sure that I know exactly what each operator, what each Boolean operator is doing. And the best way to understand that is a truth table. Okay, because implication can be a little bit difficult to interpret if you just use the word implication. So instead of using, oh, okay, it means implies, but what does it mean in English? Something implies something else. So don't do that, okay? Just look at the symbol, which is the double bar right arrow thing, and say, okay, this is the truth table. Okay. What about the definitions of the set operators? Okay, other than element of, which is a little bit abstract, the other ones can all be defined using element of and also conjunction, disjunction, and negation. So those are the definitions. Okay. When it comes to functions, okay, it's a little bit, that one gets a little bit interesting, okay, because a function f has to be a function f that has x as a domain and y as a codomain, first of all, it has to be a subset of the Cartesian product between x and y. So now the question is, do you understand what is a Cartesian product? Okay. Do you know what is not a subset of a Cartesian product? There are many ways for things not to be in the subset of a Cartesian product, so you have to understand that one. And then on top of that, f can map, okay, f has to map every element in the domain to one and only one element in the codomain. Okay, so I just spoke it in English. Okay, but how do we express it using the symbols, using a mathematical symbol? I can think of other ways to specify that requirement. Okay, the text, the reading material already gave you at least two ways to represent what I just said, and you can see that this particular exam gives you yet another way to express the same thing. So what that means is you also have to master, what is the existential quantifier and also what is the universal quantifier. Okay, so you have to look at those symbols and understand, okay, this means this means that. When they combine in a certain way, you also have to understand what that combination is trying to specify. Is that okay? So going through this exam 20 bazillion times is not going to help. Reading the material, locating all the definitions, locating all the concepts, and making sure that you have a crystal clear understanding of the concepts, that will help. So how do we do that? How do you make sure that you have a crystal clear understanding of the concepts? Review the notes. Okay, so go ahead. Okay, so but what does studying entail? Hmm? Write more notes? Trying to explain the concept to another person can be helpful, okay, especially if the other person understands all this material already. The tutors downstairs in Mesa, many of those tutors already have taken this class and they understand all the concepts. So instead of asking the tutor to explain to you, you explain back to the tutor and then you ask the tutor, is my explanation correct? Okay, so that's one. Yep. Say that one more time. Potentially, it depends on what you write down. You guys are forgetting that you also have a GPT TA. You're not falling for that? Okay. There are certain times it would be wrong, but you can also try out different GPTs. So you can try out Gemini, because Gemini is another GPT. I have not set up the TA in Gemini. Huh? It's worse. I see. Okay. So if you have a question, okay, if the GPT gives you the wrong answer or you think the GPT is giving you the wrong answer, you can always come to me and ask me the same question. But there's no matrix multiplication here. Oh, okay, I see. I see. I see. Okay. Okay. All right. So I'm just pointing out, a potential resource that might be useful. Because when I was a student in a class similar to this one, there was no internet. I'm that old. Okay, when I was a student in this kind of a class, there was no internet, let alone all the tools that you have access to. So, so sometimes you have to rely on this part is the most difficult for me to explain is do you know whether you have a thorough and crystal clear understanding of something? That really is a question. Okay. And I don't know how to answer the question. I just have that ability to tell whether I'm understanding something or not. Now, does that mean I can understand whatever I need to understand? No, not even close. But at least I know what I do not know in many cases. Okay. I know in many cases, oh, I'm not fully understanding this concept. I know that I'm not understanding. So that means I can make a decision. I can say, do I want to spend some more time to try to figure this out? Or do I think this is not important enough and I will just let it go? Okay. So that becomes a decision instead of an unawareness. So there's a big difference between, yeah, I kind of know that I'm not fully understanding this concept, but I don't think it's important enough. So I need to focus my time to do something else, like in your case, maybe calculus 2 or some other classes. Okay. As opposed to, I'm not even aware that I don't have a really good, crystal clear understanding of a concept. That is the difference. So this is the one part that I cannot really give you an answer because this is to me, it is a very intrinsic kind of thing. I just know whether I understand something or not. There's no process involved to to give me an answer whether I understand something or not. So, what about the rest of this class? Do you guys have any recommendation to your peers? Okay. Hmm? Yeah. Okay, all right. Well, getting other people involved can be helpful, especially if you can give people an example. Okay, okay, this is the mapping. Okay, this is F as a set. Okay, so let's work out, this particular expression thing. Okay, so you can come up with an expression that you think is going to tell whether something is a function or not. Okay, or one particular aspect of whether something is a function or not, and then have the other peers of yours to help you go like, okay, let's try to poke holes in your theory. Okay, so that would be helpful too. All right, shall we move on? I think we have beaten this particular one to death. Yes. Okay. So now that we know that this is, oh, okay, the next question has exactly the same format, but it's the only difference is what is x, what is y, and what is f. Those are the only differences. So now I think we can answer this relatively quickly because one has to do with surjectiveness. So we look at this and go like, "Eh, okay, from the perspective of whether all the elements of y are mapped to, yes, they're all mapped to. Is that okay? So for number one, the answer is true. Okay. Some people may look at this and go like, no, this is not a function. Yeah, it is not a function, but that's not what part one is asking. Okay. So you have to focus on just part one and go like, okay, the answer to part one is every element in Y are mapped to by F. Okay, done. Because J is mapped to, okay, D maps to J, and then K is also mapped to from J. Yep. So that satisfies this requirement. Number two, okay? Number two, we already talked about the semantic or the meaning, right? So the meaning of number two has to do with whether it is a function or not. And in this case, I'm really asking, is everything in X mapping to at least one thing in, by F? Okay, we don't even care whether it's mapping to something in Y. We just want to know, does it map to something? So now we have to answer the question. A maps to G, and even though G is not in Y, that is not what part 2 is asking. Part 2 is simply asking, is A mapping to something? Yes, A maps to G. Now, the fact that G is not even in Y, is not the responsibility of part two. Okay. And mm, what about J? Does J map to something? Yep, J is mentioned in one of the mapping, and then D is also mentioned. So um, that means we cannot find anything in X that does not map to anything at all, that is not mentioned as the first item of a two tuple in F. So that means part two is going to have an answer of false. Nothing in X does not map to something. Let me repeat that statement. Nothing in X maps to nothing. Or you can also say nothing in X is not in the mapping. Yep, go ahead. Nope. An empty set has nothing. A set that has zero in it is not empty, it has zero in it. Oh, okay. Alrighty, moving on to three. So from the previous discussion, we already know that three has to do with injectiveness, right? So in this case, well, it's asking, do two things in X map to the same thing? Okay, well, let's see. J maps to K, A maps to G, D maps to J. So the answer is no. No two things map to the same thing. So that means in this case, it is asking, can we find two things in the mapping F so that the same thing maps to different. mm, right. Okay. So the two different things map to the same thing, right? So the answer is nope, that is not true. So that means the answer to part three is false. All right. Number four. So we know number four has to do with determining whether f is a function or not. In this case, it is specifically testing whether everything in f can be found in the Cartesian product of x and y. Okay, but the polarity of the question is reversed. So the correct way to phrase the question is asking whether there is anything in F that does not belong to the Cartesian product of x and y. So now you take a look at this one, you go like, okay, JK looks good. Okay, J comes from x and K comes from y. AG, aha, we have a problem because where's that G coming from? G is not in Y. So that means the answer to number four in this case is going to be true. And the tuple that makes the underlined portion true is AG as a two tuple. Is that okay? So that means in your mind, or you can write it down. When you write down the question, what it is corresponding to, you have to use the right words to describe it. So as I said, number four is asking whether there are things in F that does not come from the Cartesian product of x and y. Yes. So in the case when u v is ag, then when you evaluate this expression, U is A in X is actually true, so not true is false. Okay, but that's only one side of the OR. So the other side of the OR is going to say, okay, what about G? G is in Y is false, not false is true. So that means we have false on the left hand side, true on the right hand side. But since this is an OR, the whole thing is true. So if you can find one case in an existential quantified expression to be true, then the whole thing is going to be true. Yep, because the when you apply the existential quantifier, you're looking at a gigantic or statement. If at least one of those items is true, the whole thing is true because you're looking for at least one. So we good with number four? No, no, you're not good. Okay. Uh, and that's okay. Well, I can verify that we are still recording, so you can look at the time and go like, okay, maybe an hour-ish into the recording. That's the part that is that you might need to review. Right. Okay. All right. So number five. Okay. Number five, once again, has to do with whether SF is a function or not. But this time we are looking for cases where the same thing maps to two different things. So we look at this and go like, nope, that is not happening here. Okay. J maps to K, A maps to G, D maps to J. So that means the answer to this one is false. Well, let me see. Let me double check. Uh, yep, it is false. Okay, it is false. So that means we don't have to follow with anything. So this is basically asking, um, can we find one thing, or is one value mapping to two different things? And the answer is no, it is not the case. So the answer to five is false for this particular example. We good so far? All right. So now when we get to number six, then you have to go like, oh, okay, f is not a function because we can see that AG is not in the intersection of x and y. So is that helping? AG in f is not an element of the Cartesian product of x and y. And as a result, f itself is not a subset of the Cartesian product between x and y, and that's why f is not a function. So that means when we get to number six, you skip part one, don't write anything down with part one, you go straight to part two, and then you say, um, and then you have to say what reason do we have to say that f is not a function, and that has to do with part four this time. When f is a function, all two, four, and five have to work together. When f is not a function, then one of them is already enough as a reason. Is that okay? All right. So do you want me to kind of repeat this kind of question a little bit more, or do you want to skip to the last question, which is the only one that is not of this format? Last question, okay? Because I can give you the key to the entire thing, right? So you can work out, all of the other ones. So the last one in this particular test, I think is one of the easier ones. It has to do with Cantor's pairing function. It is number 8. All right, so this is number 8, and it is part 1 for 20%. It is asking you this question. Use the g function mentioned in the Aleph No module to compute the natural number corresponding to coordinate 3122. For conciseness, we are going to use k to represent the answer of this particular part of the question. So what do? Well, you have to know what g is, right? So you have to know what is function g, which is also known as Cantor's map pairing function in the Aleph No module. Okay, so this is the part where just studying is enough. Okay, is to find out, okay, where are the definitions and what is the definition? Write it down. Okay, so in this case, it would be 30. It's 31 plus 32, the whole thing, times 31 plus 22 plus 1, the whole thing. Divide the product by 2, and then plus the y, which is the 22. Okay, so I can do it on the whiteboard, or just use a text editor to do this. Okay, so let me do this part here. And I think I don't need to maximize this anymore, which makes it possible for me to use a text box in the screen, like so. Okay, so BC, this is my calculator. Okay, so we have, let me see, what was the question? see. 31 and 22. Okay. There we go. All right, so it is 22 plus 31 times 22 plus 31 plus 1, the whole thing divided by 2 plus 22. And oh, am I missing something? Hmm? The parentheses. Oh, because I'm missing the multiplication here. I wrote it as if I'm just specifying an expression, but since this is actually a calculator, oh, you guys cannot really see it, can you? Me Give me a second. I just need to change the font size. There we go. I think we can see it now. So that is K. Okay, K as a constant is just 1,453. Okay. So that's part one. Okay, part one just wants to make sure that you know what is the G function, go through the calculation, and give me the value after the calculation. Yep. So you should probably quote the function itself so they can show me the actual calculation. Hmm. All right. So part two says without using the G function again, explain how you can compute the value of G of 30, 23 by using K, 30, 23, and other constants, and only involving additions, subtractions as operators. Show your derivation work here, reference definitions introduced in class, and connect your steps using logical and or mathematical explanations. So this one, I do want you to fully explain your why or how you can compute G of 30, 23 by only using K and then only additions and subtractions of some kind. All right, so how do we answer this question? So there are several ways to proceed with this one. The first one is I don't know even where to start. So what you do is you just go ahead and plug in these values and recompute the G value for this particular coordinate. Okay, so we'll go ahead and do that with the calculator, but don't write it down as a part of the answer. Okay, so in this process, I'm only trying to look for a pattern. So later on, I can potentially use it to answer the actual question. So let me find the proper box. Like, wait, it's not this one. Is it this one? Yep, it is. Okay, very good. So this time we want to figure out 30 and 23. So we have 23 plus 30, the whole thing times 23 plus 30 plus 1, the whole thing divided by 2, plus the 23. Okay. When you just look at the two expressions, you can go like they're off by 1. That's a fancy way to say they're off by 1 because 22 plus 31 is the same as 23 plus 30. So that means this is the same as this is the same as this, and this is the same as this. Oh, only one has a plus 22, the other one has a plus 23. They're only off by 1. Indeed, they're only off by 1. Why? You're like, well, just kind of how the numbers work out? No, it is not just because of how the numbers work out. Hmm. And so the x coordinate is 1 less than before, and the y coordinate is 1 more than before. Why is that significant? Exactly, it's because of the way we filled natural numbers to the tiles. We go diagonally and we go in this direction, right? So the consecutive numbers are assigned to everything along the same diagonal line, but every pixel on the same diagonal line is one up and one to the left. The one up means the y coordinate is increased by 1. One to the left means the x coordinate is decreased by 1, which fits the pattern that we're looking at here. right? So that means once you have made that observation, you can describe your observation. Okay, you can say, okay, because of the way we fill the numbers in a diagonal way, when a pixel is one on top and one to the left, the number only increases by one. Then you can say, oh, okay, in this case, g of 30 comma 23 is k plus 1. That is the bottom line. It is just 1 plus whatever we had before as k. Is that okay? Yeah, yes. Say that one more time. So you need to get part one correct first, right, in order to get to part two. Yep. That is correct. There's no way I can score part two without any answer to part one. That would not be possible, right? Yep. All right. So part three is asking for a generalization. Okay. It is simply asking if I already know that k is g of xy, x being a specific value, y being another specific value, I want to calculate g of x minus 1, y plus 1 in general. How do I do it? Okay, same explanation. Okay, you just go by the same explanation. You can say, refer to part 2. Okay, so in this general case, g of x minus 1, comma, y plus 1 is also just k plus 1 for the same reason. It's just, in this case, it's just more generalized because I don't. There are certain values of x and y that do not work out in this case because you're at the end of the diagonal line. Okay, but for the most part, it does work out. Are we good so far? Okay, so the only time it doesn't work out is when x is 0 to begin with, because x minus 1 is not even a natural number. But we need natural numbers on both axes of the three-dimensional space. So that means, you cannot work with the case when x is 0 to begin with. Yep, we are jumping all the way back, but when x is 0, the coordinate of x minus 1, which is negative 1 and something, that is not in our domain to begin with, because our domain is natural number Cartesian product with natural number. And if x is a 0, negative 1 is not a natural number. Yeah, you can draw pictures. Yep, yep, correct. Yeah, you can draw pictures. But so the crucial part of this one is you have to know how the numbers are assigned. And not only how G looks like as a formula, but why it works as a formula like that. Okay, so that's kind of what I'm referring to as a thorough understanding of the concept. It's not just knowing what things are, but also why they are the way that they are. All right, so I think that pretty much covers the entire exam. And you can always find me. I'm usually available in the morning from 8 to 9. That's my office hour. And I'm usually available right before this class too. So if you have any questions, before class, you can just knock on the glass door, leading to my office. Okay, if I'm in my office, I can hear your knocking, and I'll let you in, and we can have time to talk about stuff. In fact, I have an hour and a half, before this class. Hmm? Monday. Yep. Yep. So we are using the entire lecture for the exam. So for people who can get this done like really quickly, they can either kind of stay and double check and triple check, their answers, or they can just go like, okay, I think I'm done, and they can walk out, and have an early day off. Correct. You will, right. I haven't decided yet, so unless I have too much time on my hands, I would probably keep the format of the exam to be about the same, but the quantified expressions would not be the same. So I will find some other way to describe, oh, this is related to injectiveness, or this is related to one of the properties of being a function. So those would not be the same, um, guaranteed not be the same. But it will still have the same scope of asking, the questions about, okay, what is a set? What are the set operations, and so on. Yep. Go ahead. So in this one, the actual number is only six because out of the first seven, I only need you to answer five of them. Yep. Hmm? Nope. The rest will not be graded. I will only grade the first five out of the seven that you answer. So if you answer all seven out of seven, I will only grade the first five, and then the other two will not be graded. Correct. You can choose out of the first seven which five you want to answer. Yep. Okay. Nope. I I will grade the first five that has an answer. Yes. I'm referring to how we fill the numbers. Zero, zero, one, and then two. Yes. Okay, so you need to review the video because I'm pretty sure I drew that picture. Yep. Okay. Okay. Your question is reconfirming that you would benefit from rewatching the video. So the third one is here, three, four, five, and then six goes and go on like that. So yeah, but if you're missing that part of the lecture, you probably will be missing most of the other concepts that we talk about in that lecture, which means revisiting that lecture is going to be helpful. Yep. Do you know where to find the lecture recordings? The Canvas site has a link to the YouTube channel. Yep. Yep. Mm-hmm. Mm-hmm. Well, you can either do it that way or you can do it in the algebraic way, right? Because in terms of algebra, you can look at the two. If I were a student, I Okay, so it depends on whether you are an intuitive kind of person where you want to explain it using the picture of this is how we scan the lines and whatnot. But if it was me, which prefer a full mathematical explanation, then I would expand g of xy, and I would also expand g of x minus 1 comma y plus 1, and then use mathematics to prove that, see, they're off by only one. No matter what x and y are, the difference between these two is only one. And therefore, the answer is also just k plus 1. Hmm? What do you mean by the ordering of the concepts? Typically, that's how I would like to order things. So the aleph no is usually at the end. But it doesn't hurt to scan through all the questions first. Make sure that you get an idea of, okay, these are the questions, and then you can decide for yourself which one seems to be the easiest, and then start with that one. It depends. Some people find the set notation ones with all the quantifiers to be more difficult, and this one is just numbers, and they feel more comfortable with algebra, so they would pick this one first. Other people would look at the this one and go, like, I don't work with numbers and values, and I would work with the other ones first. So it is entirely up to you to choose which one seems to be. Hmm? Well, in the exam from last semester, yes, which may or may not apply to yours. You have to read your own instructions. That's what I said at the very beginning of the class. This is what I do not know how many questions you're going to get. Yep. Yep. Yes. No, X is so the 5 has the so 1 is has a value of 4. 0 2 has a value of 5 because we move to the left as well. Because 2 is the Y for this entire row, and then 0 is the column, right? So X minus 1, Y plus 1. Yep, correct. To move up and also, right, correct. To move to the next diagonal tile, we add 1 to the Y, but we subtract 1 from the X. Yeah, yeah, that will be fine. Yep, correct. Yep.